and here you can sometimes hear it grating the particles of sand against each other if you listen very carefully. But there is another reason why falling water makes a sound, and often even a loud roaring noise in the cataract and the breaking waves of the sea. You do not only hear the water dashing against the rocky ledges or on the beach, you also hear the bursting of innumerable little bladders of air which are contained in the water. As each of these bladders is dashed on the ground, it explodes and sends sound waves to your ear. Listen to the sea some day. When the waves are high and stormy, you cannot fail to be struck by the irregular bursts of sound. The waves, however, do not only roar as they dash on the ground. Have you ever noticed that they seem to scream as they draw back down the beach? Tennyson calls it the scream of the maddened beach dragged down by the wave, and it is caused by the stones grating against each other as the waves drag them down. Dr. Tyndall tells us that it is possible to know the size of the stones by the kind of the noise they make. If they are large, it is a confused noise; when smaller, a kind of scream; while a gravelly beach will produce a mere hiss. Who could be dull by the side of a brook, a waterfall, or the sea, when he can listen for sounds like these and picture to himself how they are being made? You may discover a number of other causes of sound made by water if you once pay attention to them. Nor is it only water that sings to us. Listen to the wind, how sweetly it sighs among the leaves. There we hear it, because it rubs the leaves together and produces the sound waves. But walk against the wind some day, and you can hear it whistling in your own ear, striking against the curved cup, and then setting up a succession of waves in the hearing canal of the ear itself. Why should it sound in one particular tone, when all kinds of sound waves must be surging about in a disturbed air? This glass jar will answer your question roughly. If I strike my tuning fork and hold it over the jar, you cannot hear it, because the sound is feeble. But if I fill the jar gently with water, when the water rises to a certain point, you will hear a loud, clear note, because the waves of air in the jar are exactly the right length to answer the note of the fork. If I now blow across the mouth of the jar, you hear the same note, showing that a cavity of a particular length will only sound to the waves which fit it. So do you now see the reason why panpipes give different sounds, or even the hole at the end of a common key when you blew across it? Here is a subject you will find very interesting if you'll read about it. I can only just suggest it to you here. But now you will see that the canal of your ear also answers to certain waves, and so the wind sings in your ear with a real, if not musical word. Again, on a windy night, have you not heard the wind sounding a wild, sad note down a valley? Why do you think it sounds so much louder and more musical here than when it is blowing across the plain? Because the air in the valley will only answer to certain set of waves, and like the panpipe gives a particular note as the wind blows across it, and these waves go up and down the valley in regular pulses, making a wild howl. You may hear same in the chimney or in the keyhole. All these are waves set up in the hole across which the wind blows. Even the music in the shell, which you hold to your ear, is made by the air in the shell pulsating to and fro. How do you think it is set going? By the throbbing of the veins in your ear, which causes the air in the shell to vibrate. Another grand voice of nature is thunder. People often have a vague idea that thunder is produced by the clouds knocking together, which is very absurd if you remember that clouds are but water dust. The most probable explanation of thunder is much more beautiful than this. You will remember from lecture that heat forces the air atoms apart. Now, when a flash of lightning crosses the sky, it suddenly expands the air all around it as it passes, so that the globe after globe of sound waves is formed at every point across which the lightning travels. Now light, you remember, travels so wonderfully rapidly, 192,000 miles in a second, that a flash of lightning is seen by us and is over in a second, even when it is 2 or 3 miles long. But sound comes slowly, taking 5 seconds to travel half a mile. And so all the sound waves at each point of the 2 or 3 miles fall on our ear, one after the other, and makes the rolling thunder. Sometimes the roll is made even longer by the echo, as the sound waves are reflected to and fro by the clouds on the road. And the mountains we know the peals of echo and re-echo till they die away. We might fill up far more than an hour in speaking of those voices which come to us as nature is at work. Think of the patter of the rain, how each drop as it hits the pavement sends circles of sound waves out on all sides, or the loud report which falls on the ear of the alpine traveller as the glacier cracks on its way down the valley, or the mighty boom of the avalanche as the snow slides its huge masses on the side of the lofty mountain. Each and all of these create their sound waves, large or small, loud or feeble, which make their way to your ear and become converted into sound. We have, however, only time now just to glance at live sounds, of which there are so many around us. Do you know why we hear a buzzing as a gnat, the bee, or the cockchafer fly past? Not by the beating of their wings against the air, as many people imagine, and as is really the case with hummingbirds, but by the scraping of the underpart of their hard wings against the edges of their hind legs, which are toothed like a saw. The more rapidly their wings move, the stronger the grating sound becomes. And you will now see why in hot, thirsty weather the buzzing of the gnat is so loud. For the more thirsty and the more eager he becomes, the wilder his movements will be. Some insects, like the dronefly, Tenex, force the air through the tiny air passages in their sides, and as these passages are closed by little plates, the plates vibrate to and fro and make sound waves. Again, what are those curious sounds you may hear sometimes if you rest your head on a trunk in the forest? They are made by the timber-boring beetles, which saw the wood with their jaws and make a noise in the world, even though they have no voice. All these life sounds are made by creatures who do not sing or speak,